So this is 1 watt meter. This is the second one. This is the third one. Each one of them will have current measurement and voltage measurement. Means an ammeter within it and voltmeter. Ammeter and voltmeter. So this is wattmeter 1, wattmeter 2, and wattmeter 3. 3 wattmeters. So the current one is going to measure the current, like you insert an ammeter in the circuit. In every one here. The voltage is going to measure the voltage. So from this point, this is going to measure the voltage here, and this is going to measure the voltage here. Then the other terminal and the voltage, they're connected together. So they're connected together. If there is a neutral, they're connected to the neutral. If there is no neutral like delta, they're just connected like that. So this is 3 wattmeters. Each wattmeter is going to measure the power in one phase, which is basically V phase, I phase, cosine the angle. So the total power will be just the sum of the 3. The wattmeter 1 plus wattmeter 2 plus wattmeter 3. That is the total power in my load. It can be delta or Y. This works all the time. Each wattmeter will measure power in one phase, and the total power in the 3-phase load is going to be just the sum of the 3 readings. Now, 2 wattmeter technique works all the time except one case that doesn't work. So 2 wattmeter, we're going to keep one line as a common, and we're going to do 2 wattmeters. This is 1 wattmeter. Let me make them bigger just so you can see the connection. So it has 2 terminals for the current, 2 terminals for the voltage. Sometimes they call it current coil, voltage coil. So current, voltage, this is to measure the current, this is to measure the voltage. Now this is the positive of the voltage, this is the positive of the current, this is the positive of the current, this is the positive of the voltage. So the current, when we connect it as an ammeter in the circuit. Same here. The voltage now is not the phase voltage, it's going to be the line voltage. So between this point and this line. Same here. This is going to go to that point, and this is going to be here. This guy is going to have 2 powers. The first wattmeter is different than the second wattmeter. They're not equal. But the total power is like here. The total power is the sum of P1 plus P2. Now these 2 wattmeters, when you add the readings, it's going to be like those 3 wattmeters. So now, because it's going to measure the phase, the line voltage and the line current. Okay. When you multiply cosine, these 2, they don't have only theta between them, because V line has a 30-degree plus the V phase. So you're going to have theta plus 30. And I'll show you why we have this. The second one will be V line, I line, cosine theta minus 30. I'll show you why we have plus 30 and minus 30. But this is it. 2 watt meters, 3 watt meters. Someone would be like, okay, why we have B common here? You can have C as common and you connect 1 watt meter on A, another one on B, the third one, the C is a common. What is common? It means the voltage is connected to that. The voltage common is connected to that point. So this is basically it. These are the formulas that we need. Okay, these are the formulas that we need. 3 watt meters, we use phase because each one is per phase. 2 watt meters, we use line values because the voltage is between lines, line A and line B. Here, the voltage is between the line and the neutral. Even if I don't have a neutral, I create a neutral. If there is a neutral, I connect to the neutral. If there is no neutral, I create this neutral by the 3 negatives are connected together. Now this, the 3 watt meter, this one, makes normal sense because each one will measure the phase, the power going to one phase, the power going to another phase, the power going to the third phase. 3 powers are equal if the system is balanced. I add them, they give me that, no problem. Phase voltage, phase current, cosine the angle between them. This is the power. Now the problem with this guy, 2 watt meter. Why does the 2 watt meter looks like this? This is a little bit of details. Now the 2 watt meter is more common because it uses only 2 watt meter. But it doesn't work in one case when you have a neutral and the system is not balanced. So when you have load that has 3 wires, then in neutral, and the system, this is not balanced. So if the system not balanced, this doesn't work. Now for us, we're gonna always have balanced system. So it's gonna work all the time. And if it's unbalanced, we're not gonna have a neutral, so it still work. The only case when you have a neutral and the system is not balanced. That is the case that doesn't work. So it works most of the time. And because it uses only 2 watt meters, it is better than using 3 watt meters. So now look at this one, the current IA. This is what is measured, the voltage VAB. We know VAB is the line voltage, so it's square root of 3. VAN, the phase, and 30 degree. So we're adding 30 degree. This is why we add it here. Okay, this is why we add it here. The angle is not going to be theta only. There is 30 degree added between current and voltage. Now this one here is measuring V between C and B, the other phase here, C and B. This is not VBC, so it's flipped. So the angle is not 30, it's going to be minus 30. We know the sequence for us, VAB, VBC, VCA. Any one of them flipped is going to be the negative angle. Like here, CB, not BC, because C is the positive, B is the negative. So it's VCB here. So since it's flipped, it's going to have the negative angle. Now, another thing, sometimes, let me just do this. I'm going to show you some case, but all the time use this case, which is easier. Now, let's say that you changed your mind and you said, I'm not going to put my watt meter here. I'm going to put my second watt meter here on the second line. This is the current. And this is the voltage. This is the common line. Now, C is common. So this is going to measure between C, between B. B is connected on B. So B is the positive and C is the common. This one, A is the positive and C is the common. So now what is common is C. The first guy, this one, will measure VAC. VAC. This guy will measure V, BC. Now, according to the sequence AB, BC, CA. So BC is okay. So this one will have V line, I line, cosine theta plus 30, because the voltage is not flipped. It's between B and C. Now the first one, VAC, is this voltage, but it's flipped. So this one is the one that is going to have the cosine theta minus 30. Anyhow, you know that one of them is going to have cosine theta plus 30. The other one is going to have cosine theta minus 30. If you do them in A and C, it's going to be A is the positive, C is the negative. If you do them A and B, B is going to be the positive, C is going to be, A is going to be the negative, because this is BC. BC is still the same sequence. This is AC, it's opposite of what we have. This might sound complicated, but when we look at the lecture, it's not very complicated. We're going to look at the lecture and we will see. Always use one case so you're not confused. Use one case, you're not confused. So let me just share the lecture with you guys. So we did this, and we did this 3-watt meter. This is how we connect them. We can use, as we said, we can, last class, we can use the coils, or we can use the ammeter, voltmeter. So a watt meter can be represented like this. Terminals for the ammeter, terminals for the voltmeter. Ammeter is connected like this here, voltmeter is connected like this. Or we can use coil and coil, and we can connect them like this and say, okay, this is, for example, the positive, this is the positive. Or we can connect them this way. I like this way easier, positive and positive, so they don't get lost here. Positives are connected together. It's okay. Now see, current is going this way, so the positive here, the negative here. If you put an ammeter, and if you put the coil, is the same. Current coil is called. Voltage is between positive here and negative here. Voltmeter, or if you do a coil, whatever you connect here is positive, whatever you connect here is negative. You see this one here? See, this is the current, the positive from here. This is the voltage coil, the positive is from the A. Do the neutral, this is the neutral. We create a neutral if we don't have a neutral. We will show you the, so I think we did this anyway last time. We did this. This is the 2-phase, the 2-watt meter. Now in the 2-watt meter, if you add this power and this power, you're gonna get this, which is the 3-phase. This is why 2-watt meters will give you the 3-phase power. If you add this and this, it's gonna be this. Now in your math class, you did what they call them, the trig identities and the sum of angles. So cosine angle plus angle gives you cosine, cosine minus sine, sine. So cosine of the first one, cosine of the second one, sine of the first one, cosine of the second one. This one here is the same thing. When you add these ones, the sines will cancel out. You will have the cosine, so you're gonna get this one. You can try to do that, but for sure, P1 plus P2 will give you the total power, which is 3-phase power. Now, if you subtract P2 minus P1, will give you this term. This term, basically, if we multiply it by square root of 3, it gives me Q. Remember, P equals to 3 V phase, I phase, cosine the angle, or it equals to square root of 3 V line, I line, cosine the angle. Q is the same thing, except it is sine the angle. When I subtract B2 minus B1, I get this. If I multiply it by square root of 3, gives me Q. So this gives me the second formula here. Now, when Q is 0, the load is resistive. Okay. When Q is positive, the load is inductive. When Q is negative, the load is capacitive. We know that from fundamental 1. If we don't know that, we have to know this. So if we have a capacitor, it gives me negative Q. If you have an inductor, it gives me positive Q. If you have only resistor, it gives me 0 Q. So give me power here, P. Here P is 0, P is 0. But this gives me actually P. Now, so if Q is positive, it means this is bigger than this. Okay. If Q is negative, it means P1 is bigger than P2. Now we will see in the exercises that, okay, here's an example. Now, in this example, it says redraw the circuit, connect 2 watt meters. Okay. So I'm gonna connect 2 watt meters to measure the power. Then calculate the watt meter readings. So the answer is in the next page. So this is how I connect the 2 watt meters. Okay. Now you don't have to do positive and negative, but it means what this means, if the positive of the coil here, the current here is positive, the voltage is positive. I would always use this shape. It's easier for me as a watt meter. This is a current coil. This is a potential coil. If I put this is positive here for the current, this is the negative for the current. Positive here for the voltage, negative here for the voltage. If you flip the current polarity, you have to flip the voltage polarity. But don't flip it, just keep it that way. The current is going to the load, the voltage, this is positive and the ground. So this is the first watt meter, this is the second watt meter. I'm keeping P is a common. So 1 watt meter on A, 1 watt meter on C, P is the common. What is the common? Common for the voltage. Now for this circuit, for the circuit, this is the reading of the first watt meter. This is the reading of the second watt meter. 3 values I need. I need to know VL, IL, and the angle theta. Now the angle theta, you can find it from the impedance. So take the impedance, change it to polar, 10 and minus 53.1. Just change it to polar in your calculator. This is the angle. This is theta. So theta is the angle between the voltage and the current, but at the same time, it's the angle of the impedance because voltage and current, V over I, give you Z. So theta V minus theta I will give you theta of Z here. Will give you theta of Z. So one thing, this is if you have load and the phase angle of the load. Now what we have here, Y to Y connection, I can take single phase like this, divide this voltage by this impedance, I get the line current. So this is the line current. I don't need the angles here because I'm using RMS. Then if I want the line voltage between here and here, in Y connection, I take the phase voltage multiplied by square root of 3. I get the line voltage. So I have the line current, the line voltage, and the angle. I just plug them in. I get the 2 watt meter readings. I hope this is okay. This question is exactly your lab question, just different numbers. Your lab 8. So keep this in mind when you do the lab question. Keep this in mind so you can do that. Okay, I'm gonna take the attendance and give you some time to look at this, some time to look at this question. In the assignment, there are questions like this. In the assignment 5, not 4, 5. Okay, 4 is already there. 4, 4, 7, and 8. This is lesson 9. 9 and 10 is assignment 5. I'll give you a few minutes so you can try this while I'm gonna take the attendance. Do it, do it. I feel like I'm talking to myself, but hopefully not. I know from the midterm that some people did fine. Some people made small mistakes here and there, and their mark is not really good, but they're actually, I can see that they're actually getting close to understand this stuff. Today is the 7th. Okay, Abdullah Khalid.
Yes, sir.
Thank you. Muhammad Mohsen. Hassan, Abu Hassan. Rand.
Yes.
Thank you. Yazan. Sarah. Thank you. Abdullah Ali.
Yes.
Thank you. Miriam Ahmed.
Here, mister.
Thank you. Abdullah Ahmed. Ahmed Al-Tayyib. Asma.
Yes.
Thank you. Muhammad Yusuf.
Yes.
Thank you. Leen. Thank you. Fahad. No. Amal.
Yes.
Thank you. Abdullah Hassan. Here, Hazim.
Yes.
Thank you. Samar. Thank you. Zaid Ali or Ziyad.
Yes.
Thank you. Awatif. Wissam. Manal. Thank you. Hamad. Asia.
Yes, sir, I'm here, Hamad.
Okay. Asia. Yes. Thank you. Sharif. And Ahmed Ayman. Okay. Thank you. So we'll go back to the lecture. We'll do a couple of exercises, then I'll let you go. We're not gonna finish today. There's no chance. So we'll do this and 3 and 4, then I'll let you go. So 2 watt meter method produces this reading. So the first watt meter gives me this power. 1560 watt. The second watt meter gives me this reading. So they're already connected and measuring, and they give me this measurement. The question says calculate the power per phase. The per phase average power. Average means the real power. Q per phase, so for one phase, not for the 3 phase. And the power factor. Now, one phase power means the total power, the three-phase power divided by 3. And this is just Q total divided by 3. Power factor is P divided by S. You can use the total or per phase, it's still the same. Okay. So per phase power means one phase power is 1/3 of the three phase. Three phase, each one of them will have some power, they're equal. When I get the total power, it's 3 times of one phase power. That should make sense. And that means we need to find what is the total power. From the readings, okay, I'm gonna put here, total power is basically that's the sum of these two. 2 watt-meters, they're gonna measure the total three-phase power. So P1 plus P2, and it's going to give me 1560 plus 2100. So a total is 3660 watt. So I'm gonna answer here. 366 is the total divided by 3. This gives me 220 watt. That's the first part. Now it says Q, so I'm gonna find Q total. Which is, we said the difference multiplied by square root of 3. So P2 minus P1. No, square root of 3. P2 is 2100 minus 1560. This is gonna give me I think 935 point something, 0.3 I think, volt ampere reactive. So I'm gonna plug it in here. 935.3 divided by 3, so it is 311.8 volt ampere reactive. Now I want S. The apparent power is P squared plus Q squared under the square root, Pythagorean, right triangle, remember. Oops. This is P, this is Q, this is S. So I'm gonna plug the values. 3660 squared plus 935 squared under the square root. This gives me 3777.6 I think volt ampere. So I can plug it in here. 3660 3777.6, gonna give me 0.9 something. 100 divided by 97 I think, and it is lagging. Why it is lagging? Because Q is positive. If Q is positive, it's inductive. If we go back one step here to see, here this is P total, P1 plus P2, which is, we said, Q total, square root of 3 P2 minus P1. And if P is positive, Q is positive, the load is inductive. P2 more than P1. And this is P2 more than P1, means when we subtract, it's gonna be in the positive value, so that is inductive. So this is the answer for this question. This is, if you have the readings, how can you find the total power? How can you find the per phase power? How can you find the total Q? the per phase Q, okay, the power factor. I think those are questions in lab 8. Okay, so once you do the measurements, you're gonna use the measurement to calculate the total P, the total Q. Any questions here? Okay, so we will continue. Another question, and we will stop here. We can actually do one more. How many we have? 2. Okay, we actually can finish. Okay, so we will see. 3-phase balanced load. This is the load. Impedance per phase. Each one of those impedances is this value. Connected to line voltage of this. So the voltage between line and line is this value. What is the reading of the 2 watt meters, and what is the total P, and what is the total Q? So what they want, the reading of the first watt meter, the reading of the second watt meter, and they want the total P and the total Q. Now the reading of the first watt meter is actually V line, because now 2 watt meters, this watt meter will measure the line voltage and the line current and the angle between them, which is cosine of theta plus 30. The second one will measure V line, I line, cosine of theta minus 30. See, the first one measures the voltage. See the voltage between A, this is the voltage coil, A and B. VAB is 30 degree more than the phase voltage. The second one measures between C and B, not B and C. It's the opposite, measures C and B. So the voltage here is positive and there is negative. It's not going through the sequence, it's opposite. So this is why it's negative. Now, what do we need to know? Oh, let me continue here. This is just the P1 plus P2. So the reading of the first watt meter plus the reading of the second watt meter. And this is square root of 3 times P2 minus P1. P2 minus P1. So what I need to know to apply here so I can find, I need to know a few things. First, I need to know the angle theta. And I need to know the I line. And I need to know V line. Let's look at what we have. We have Z equals to, what is the 8 plus J6. And we have V line, it's given to us, equals 208 volt. So this is one of the things that I want. I got it. I need them here, V line, L line, and the angle. The second thing, the angle, how can I find it? Z, I write it in the polar form. 8 plus J6, it's going to be equal to 10, angle 38 point, I think it's 38.9. You can guys check this. So this is ohm. So from here, theta is this angle 38.9. I got theta. $36.8, thank you. So 36.8. So 36.9, I think 0.87, it's 36. 36.9. So I got the second one. Now I need to find the current here, the line current, which is, because the load is Y, equals to the phase current. So I need to find the line current, but it does equal to the phase current. Oops. The phase current. The phase current, Ohm's law says phase voltage divided by phase impedance. So I need the phase voltage. Because this is a Y connected load, phase voltage is V line divided by square root of 3. I'm not going to add the angle because I only need the magnitude, the RMS value. So it's 208 divided by square root of 3. It's 120 volt. So here it's 120 volt divided by Z. I'm just going to take the magnitude 10. I don't need the angle. So 12 ampere. So IL equals to 12 ampere. I got the three values I can plug in. So I'm going to plug them, 208. The current I line, cosine, the angle was 36.9 or 0.8 or something. I think it's 0.9 plus 30. Can someone give me the answer for this? So this one is the same thing, 208. The V line, I line is a 12, cosine 36.9 minus 30. So this will give me the answer here. Once I have these two, I can plug them here. Can you do the calculation for me, please? $13. Are you sure? I think it's a little bit more than that. Just make sure.
Sir,
Yes.
979.2.
For the
You
first
asking
one?
For
the first one?
yeah,
So
979.2.
Okay. So it is 144 times 8.
979.
Okay. 179.2. I'm just doing it in my mind so I can actually confirm. So this is what? And what is the second one? Oh, 24 something? 2477?
2477.9.
Oh, it's here. 2477.9 watt. So this is 0.9 plus, I just wrote the second one before. 979 point, about 0.3. So this will give me about 3,456 watt, something like that. That is 6. That's 4.
57.
Okay, something very close. So square root of 3 the value of the second one minus the first one. So 2477.9 minus 9.2 or 0.3 or okay. And this should give me I think 2592 volt ampere. Okay, so this is the answer for this one. Okay, I want you to review those questions, review the connections, review the exercises, okay, the examples, and copy this one anyway just before we move on. And then the last two questions, we will do them tomorrow morning. And so we can start lesson 10 after that. So tomorrow we're gonna do lesson 10. Probably we will finish it on Thursday. Then next week we have 1, 2, 4 hours, enough to finish. Okay. So 2 exercises, this is one. And by the way, this is exactly like exercise we did. And this is another one. So this is, look at this one. It's exactly exercise 2 that we did. It's exactly like this exercise, just different numbers. So you can try it. Then this is just power calculation. So it doesn't have to connect watt meters, just calculate the power. So to calculate the power, you can do either P equals to 3 V phase, I phase, cosine the angle. Or you can do square root of 3 V line, I line, cosine the angle. So for this one, you need V line, I line, and theta. For this one, you need V phase, I phase, and theta. Okay. Now this is Y to Y connection, so it's not difficult to find the line current. Now what you have the line voltage. Already you have the line voltage, so this is given 208. If you want the phase voltage, you take this divided by square root of 3, so this is 208 divided by square root of 3. This gives you 120 volt. The angle is given, it's the impedance angle, 45, and here is 45. So we need either I phase or I line. So the phase voltage here is 120, the phase voltage. The phase impedance is this, so you can find I phase in single phase like this, Y to Y connection, source and impedance. So it is 120 divided by 30 angle minus 45. You don't have to do, so this is 4 ampere. So this is, the phase is 4 ampere. And guess what? The line is equal to I phase because it's Y connection, is 4 ampere. So this is 4 ampere. Now you can apply these 120 times 4 times cosine and multiply by 3, or 208 times 4 times cosine of 45 times square root of 3 is going to give you the same answer. I think we're going to finish this lecture. Okay, so you can plug them here or here. So 3 times 120 times 4 times cosine of 45. Here, the other way to do it, square root of 3 times 208 times 4 times cosine of 45. Either one of them work. You don't have to do both. So one of them works. It can give you the answer. Okay, we finished this basically this lecture. Okay, this is the last thing. The question before this, so we can start a new one tomorrow. So when we go back here, this lecture, exercise, 3 watt meter, connect them. 2 minutes left. Okay, we will do this tomorrow, exercise 5. We will do it tomorrow just so we can start with something you know. Then we will continue inshallah, and have yourself a good day. The mid